This is number 17. Number 17 reads, determine whether a bond between each of the following pairs of atoms would be pure covalent, polar covalent, or ionic. In order to answer this question, we need to be familiar with this terminology. So a good study strategy is to, before a test, and not the night before a test, become very familiar with what the words mean. Otherwise, we really don't have any chance in answering the question. Make flashcards if you need to. Very, very useful. Alright, so what is a pure covalent bond? A pure covalent bond is one in which the atoms, the atoms that share the bond share the electrons equally. Not one atom has more control over electrons than the other. So how do we do that? We need the atoms to be the same. Atoms are identical. Atoms are the same. And so equal sharing of electrons. Equal electron sharing. A polar covalent bond is one in which the one atom has more control over the electrons than another. But the bigger atom, the atom that has more control, not necessarily bigger in size, the atom that has more control has not completely stripped away the electrons. It's just more like a tug-of-war game where one team is starting to win, the other team is starting to lose. So here, the atoms are not identical, atoms not the same. One atom has more control than another. Atom has more electron control than the other atom. Whereas in an ionic bond, it's like a tug-of-war game. An ionic bond is where one atom completely strips the electrons from the other atom and keeps them to himself or herself, depending on what the atom is. So, atoms again are not the same. Atom has complete control. Atom has complete electron control. So, relating this back to our tug-of-war example, a pure covalent bond would be where there's a tie between the two sides of tug-of-war. A polar covalent bond would be where one team is starting to win, one team is winning in the process. Ionic bond is where one team has already won. Game over. Okay, let's also do a little more descriptive on polar and ionic. How can we further identify these two? This is more just definition. How can we identify them? It's easy for pure. We just have to find where the atoms are the same. That would be up here, nickel, nickel. Boom, pure. We don't see that with any of the other bond types. So we have to look further into it. Polar is a bond between, now here's the big guy, here's the star of this whole question. Polar bond is one between two nonmetals. Two nonmetals. How do we know what's a nonmetal? Check out my handy-dandy periodic table. Nonmetals are going to be found, let's see, 1, 2, 1, something like that. This is my little example of the semi-metals down here in this little diagonal. They usually have different color in your book. These are going to count as non-metals for our purposes, although technically they're only semi-metals. Over here, on this side, are the non-metals. Oh, and all over here are the metals. Okay, so whenever you have two nonmetals, two guys from this group, they're going to make polar bonds. So where does that occur? Well, boron is actually a semi-metal, so we're going to count it as a nonmetal for our purpose. Oxygen is a nonmetal, so we have two nonmetals, so this should be polar. We have a strontium, which is in the metal side, and an oxygen, so it's metal plus nonmetal. Well, it's not polar, that's not pure, so it's got to be ionic. Ionic is a metal plus a nonmetal. And we call this a salt. Classic example would be sodium and chloride. Sodium's a metal, chloride's a nonmetal. Okay, strontium, oxygen, so that would be ionic because, again, metal, nonmetal. Arsenic, bromine. Arsenic is a semimetal, and bromine is a nonmetal. So this is going to be a polar, just like up here with a boron. And finally, we have cesium and chlorine. Cesium is a metal, chlorine is a nonmetal. So that's going to be a salt, also known as, also has ionic bond in it. There we go. That's how we answer this question.